I'm inserting this extra lecture just to go over how to use Excel to do time value money problems. It's come to my attention most of the class is using Excel, which is fine. Should be able to do any of the problems we do in this class in Excel. In fact, you can do a whole lot more in Excel than you probably can on a finance calculator. So it's an excellent resource. But I wanted to have a real short little video here just to go over the basics of how to use the finance functions in Excel in case you get stuck on a problem or something and need a little extra help. So I've stuck up here a standard time value money problem. I don't have an actual word problem to go with this. This isn't like a real world problem or anything, but these numbers all do work within a finance calculator, meaning if you plugged any of these four variables in, you could solve for the fifth one. So these always equal out. So you can make up whatever problem you want to make up that has this particular inputs. But this is a valid time value money problem. So if I plugged in these four and solved, it would come up with n is 15. If I plugged in these four and solved, it would come up with present value is negative 935, and so forth. Pick four, solve for the fifth, it'll come up with the other one. So I'm going to go over to Excel here, and I have these same five numbers on the same variables, N, I/Y, PV, payment, and future value. And I'm just going to go through in each case and show you how to solve for, if you had four of the five, how you'd solve for the fifth. Once we do these basic time value money problems, then we'll go look at the uneven stream of cash flow problems where we'll solve for net present value, internal rate of return, things like that. So first off, let's solve for the number of payments. So pretend I didn't know n was 15, so block that out. But I knew the other four. If I wanted to solve for that, what that n should be, click on this cell down here next to n, and I go up to formulas, and there's all these different tabs up here, but I'm going to click on formulas, insert function, and then there's a whole bunch of different types of formulas in here. I'm going to click on financial, and then the one you want to use is NPER. I click OK. These formulas always kind of tell you what to do. So it says rate. You got to put a rate in. Well, I have the rate is 13%. So I click over here on cell B2. It says B2. Now 13 is going in there. Payment. How much is my payment going to be? It's going to be $120. I click on B4. Present value. That is my negative 935.38 cents. And then I happen to have future value. I need to make sure I put that in there. And then there's a type. That's where you could put in a 0 for an ordinary annuity and a 1 for a beginning of period. If it's 0, you can just leave it blank, but I'm going to go ahead and put in a 0. That means it's a regular annuity. And then I click OK, and it solves 14.997. There's a little bit of a rounding error, but basically it came up with 15. I can go back here and hit home and remove some zeros if I want, and eventually it does show 15. So that's the number of payments. What if I knew everything but I/Y and wanted to solve for it? Again, I'm going to go up here and click formulas, insert a function. This one is called rate, so I'm going to scroll down until I get to a function called rate, a formula called rate. Click on OK for that. It's got all our same NPER. Again, is the number of payments, that's 15. Payment is 120, present value is that, future value is that, and then click OK down here. 13% matches up. Alright, what about present value? Insert function, formula, go down to PV, click OK, rate, number of payment, future value, click OK. Made it red because it changed the formatting of the cell, but it's the same number, 935.38 cents. What about payment? Insert function. I believe it's just PMT. There it is. Click OK. Put in the rate. Put in the number of payments. Put in the present value, future value. Click OK. Comes up with $120, which matches up. And then lastly, let's solve for future value. It's just FV. Instead of having to go through the formula, you can actually just type in the name of the function, put some parentheses. It's a little bit quicker sometimes to do it this way instead of going through insert function. But it tells you what it wants in a row here inside the parentheses. First it wants the rate, then I put a comma, then it wants the number of payments, put a comma, then it wants the payment, put a comma, then it wants, when it puts it in brackets, that means it's optional, but we do have a present value, we want to put it in there. And and then type is optional, but if you wanted to put it in 0 for end of period, 1 for beginning of period, we want 0. Hit enter, and it comes up with 1,002 cents. A little bit of a rounding error, that's all. Alright, so that's how we use our standard 5 gray button in the middle. When you're looking at a finance calculator, you have these 5 gray buttons, which are these right here. You can do all that on Excel. Nice thing about doing it in Excel is I can real quickly change stuff. If I change that to 12%, it recalculates everything. For some reason we threw in, let me change it to 14%. Sometimes certain numbers come up with no solution to certain problems. I didn't think that through necessarily. But if I change this to 14%, it recomputes everything except for, except for the one that you're solving for down here, because it was solved with the other numbers. But if I change payment to 100, it'll recompute everything but payment again, because that's the one you're solving for. But alright, that's that. Let's move on to if you have an uneven stream of cash flows. So I've switched spreadsheets here, and now I have a set of cash flows where I have T0, which is your initial cash flow. It's usually a cash outflow, or it's usually the opposite of what all these are. So either there's one cash outflow and then there's a whole bunch of cash inflows, or there's one cash inflow and a whole bunch of cash outflows. So year 0, in this case, we're buying something, and then year 1, 2, 3, 4, 5, or period 1, 2, 3, 4, 5, if you don't want it to be in years, that's fine, is 100, 2, 3, 3, and 2. So it's uneven stream, meaning we can't use those standard 5 variables like we did in the last problems, but we can calculate a present value and an internal rate of return, which is the interest rate. So you can either say, if I discount all these back to year 0 to today and find on net what's the value of this project given an interest rate. In fact, we need to put an interest rate in here. So let's say our interest rate is, we'll just make it 10%. One thing to note, on Excel, whenever you do, even on the prior problems we were doing and on this problem, put in your interest rates as percent. 10% here is the same as, if I reformat this, is just a a general number instead of a percent. It's actually 0.1, right? That's the same thing. In fact, I can do it up here a lot quicker. If I make it a percent, it's 10%. If I go hit general, it's 0.1. When you put numbers into your finance calculator, if you have a finance calculator, you put it in as a percent. So I'd actually put this in as 10, not 0.1. When you put it into your Excel spreadsheet, you put it in as a decimal, which actually makes more sense to me. But for whatever reason, the finance calculator, once you put it in, the interest rate times 100, or the percent. So I'm going to go ahead and convert this into a percent so it's readable like an interest rate. So we have 10% is our interest rate. These are our cash flows. Let's actually start with, well, let's do NPV first. NPVs, there's a function, if I hit equals NPV, it'll do these for you. NPV stands for net present value, but it's a little bit confusing, and I'll need to show it to you. The first time you do this, it might not make perfect sense, but after you do it a couple times, it's not that hard. So what does it want here? It wants rate, and then it wants these values. First thing you do is you click on your rate, and then you put a comma. So we've got the rate, and that wants these values. Make sure I get a comma in there. You can put them in one at a time, or you can just drag a box over all of them. But the key here is it assumes you're not putting a year 0 in, which if I were writing the Excel program, I wouldn't have done that. But you need to drag years 1 to 5. It assumes the first cash flow you put in there when you drag this box over it is the first year, not year 0. It doesn't count year 0 for whatever reason. So it's a little bit tricky the first time you do this. So you need to drag years 1 to 5 or 1 to however many years you have, and then you hit enter, and it discounts all those. So the present value of all your cash inflows is $810.68, but that's not your net present value. To make it net, you need to add in, put plus, that year 0 cash flow. That's going to add in, it's essentially going to say that we calculated the net present value of all, including the year 0, but it didn't. It only did years 1 through 5. And if you actually drag all of them, it'll assume that negative 1,000 is in year 1. It'll screw everything up. So you got to do it just the way I did it here. You do net present value, rate, and then you click all your positive years, not year 0, leave it out, and then add in year 0. Year 0 doesn't need any discounting anyways because it's already in year 0. So you don't have to move it through time at all. So just add it in, and it's a negative, so it'll actually subtract out. But we come out with a negative. This is a negative net present value project, meaning we're going to lose on our wealth basis today. We would lose $189 in present value terms if we took this project, so it means it's a bad project to take. But we'll talk about capital budgeting later and deciding which projects to take or not. But that's a bad project, so we don't want to. That's the exact same number you'd get if you went through your finance calculator and did it the way I taught it in the lecture. All right, IRR will say, well, what interest rate are we earning? This one's pretty straightforward. You do the IRR function, put parentheses, and then within it, it wants all these values. Just drag over all the values, including year 0. This one, you put the year 0 in. For whatever reason with the NPV, you don't. And then you can put this guess in here. If you put a comma and then you put a guess, no problems we do, you're going to need to do that. Sometimes there's multiple answers to an IRR problem, especially if your signs flip-flop a lot. So if you go from negative to positive, back to negative, back to positive, that means there's multiple correct IRRs. There's actually a thing called modified IRR that fixes that problem, which you'd probably use instead of regular IRR if you have flipping cash flows like that. But we're not going to teach that in this class. So you won't have to worry about that guess. Just leave it and just hit enter. And 3%. And you can add some decimal places to that if you want. It's actually 2.98%, which is significantly less than 10. 10 is our required rate of return or our cost of capital. If we borrow money, that's how much we have to pay. So if we're going to borrow money at 10% and invest at 2.9, that's a losing project, right? That's a bad project, which is why we got a negative net present value. So both the answers came up with the same solution. But the key is here, this problem didn't even mean anything. I just made the numbers up. The key is just to learn the mechanics, how to use Excel. So I hope this helped. Don't forget this Wednesday, you have all your time by money stuff for the second week needs to be in. Send me an email if you have any questions, or if you have a general question for everybody, post it on the discussion board. Thank you.